So welcome to your chemistry elective. In this we're going to look at reversible reactions and how they work within the chemical industry. Okay? There'll be a lot of videos. These videos you can watch in your own time, sometimes in advance of class if your teacher tells you to. It might just be something you're using for revision, but they're there for you to access whenever you want. Now, why do we care about the chemical industry? Well, we care about it because it's important, because it takes raw materials, things that are dug up from the ground, gases we take from the atmosphere, things that plants make, and it converts them into stuff that are useful and are profitable. It's also a major contributor to the economy. Okay, and this little graph down here shows you its turnover and what percentage significance it has. So slightly on the decline in terms of significance, but more and more is being made. What's being made? Well, over a quarter of it is medicines, which are either used in humans or animals. Okay? Other major contributors, lots of paints, lots of pesticides and fertilisers used in farming, lots of resins and rubbers, and then a few smaller things like inks and cosmetics and that kind of stuff. The chemical industry, which is operating efficiently, is going to make you a lot of product, it's going to make it fast, and it's not going to cost that much to run. So those are the things we're going to be looking at in this unit to say, how can we make lots of it? How can we make it fast? And what things do we need to do to keep the cost down? They've also got to make sure that they're not damaging the environment or their employees. Now there's two basic ways that they can make them. Batch processing, we make one, we finish it, we move on to the next. Or continuous flow, which is more like a conveyor belt type approach. Okay? Both have got their advantages. Batch flow is very controlled, and if something gets damaged, it's only going to affect that one little batch, that one container. Continuous flow is a lot more efficient, but if you damage one part of it, that would affect the entire amount, and it would take a lot of money to stop and then restart the process. So, costs, which are important that we're going to be looking at. Things which could affect the expense are things like a catalyst. Catalysts, remember, they speed up a rate of reaction without taking part. Now, they might do this and be relatively cheap to buy, but they might be really expensive to buy, so we've got to have a look at that. The pressure, a reaction vessel that's high pressure can cost a lot. Temperature, hotter it is, the more heating costs you've got. Choice of reactants that you're going to use and how much you're going to use of them. And how you're going to keep it safe and minimise the amount of waste and how much you've got to pay to get rid of that waste. The other thing they've got to consider really carefully is how to be safe. Okay? And over 2,000 Australians die each year from exposure to hazardous substances. This is a number we want to keep down. Okay? We also have lots of headaches, nausea, birth defects, organ damage. Again, that's something that we need to minimise. One of the ways we do this is by clearly labelling what is in each chemical and how dangerous it is. And this is an international symbols, which is why I've got pictures as well as words, and sometimes you see just the pictures, because that way, it doesn't matter if you speak the same language, it's still going to be interpreted the same. So you'll see these on bottles of chemicals in the lab, okay? And you'll see them also on tankers that are driving chemicals around. Okay? Same symbols are used to make sure everyone understands what's dangerous about them. In the chemical industry, or anywhere where we're using chemicals, you have to do a risk assessment to make sure that you are identifying those chemicals, that you're saying how you're going to handle them safely, and how you're going to control it. Okay? And you actually have to keep all those records for 5 years. So any experiment you do in class this year, those records will be kept until 2024, when you guys are long gone and have completely forgotten about it. Okay? So we do a risk assessment that looks something like that, where we might say, for instance, we're using a chemical that's highly flammable, we're going to keep it away from sources of ignition. Okay? And your teachers always think about that in advance. On a much wider scale, people who are industrial chemists think about that for their particular industry. The other thing they need to think about is how they manage waste and pollution. Okay? If they just dump them, then there is a lot of fines, people can be taken to court, Okay, so they need to make sure that they are disposing with them in an appropriate way. And the EPA, they're the ones who monitor it, they're the ones who can then enforce those laws. What we can do, we can have landfill, we can dump at sea. Those things are allowed as long as the chemicals are made relatively safe and they're in certain amounts. We can have high temperature incineration, so we burn them until they're just a dust. We can store them in sealed drums in a secure location, which is something that happens for nuclear waste an awful lot. Okay? And you can put amounts into the water and the air, but there are very carefully controlled how much you do that. So when we're making a chemical plant, the things that they would think about are we near the raw materials? Are we near where we're actually going to sell them? Are we near where roads are so that we can get to us and get away? Have we got energy supply there? Are we able to dispose of our waste? Is there a river nearby that I'm going to pollute that's got lots of endangered species in it? All of these kind of things are considered.